So in this video we're going to do integration by parts when there's only a single function inside the integral. And because there's only a single function inside the integral, it looks up front like we can't use integration by parts, which requires a product of two functions. But the way that we can get around this is to recognize that there's one arc sign inside of there, so we can actually rewrite it as 1 times the arc sign of x dx. And if we do that, then we can let one of the functions be 1 and the other function be the arc sign function. And in this case, if we let u be the arc sign function, we can use a result from last semester where we found the derivative of the arc sign is just 1 over the square root of 1 minus x squared. So this is something we did in Calc 1. And then we can let v prime be equal to 1, which will work out nicely because we know how to integrate 1. So if we integrate v prime or integrate 1, we'll find v, and the antiderivative of 1 is just x. The derivative of x is 1, and now we have the pieces that we need for the integration by parts formula. So we can go ahead and say this integral that we're interested in, which is just the antiderivative of the arc sine function, can be found by taking u times v, so arc sine times x, or x arc sine x. So x arc sine x, that's the u times v, and then minus the antiderivative, and the antiderivative is going to be u prime times v, so it's going to be u prime times v, and when we take the product of these two functions, we're going to get an x over the square root of 1 minus x squared. And remember, the idea is that this integral has to be something that we can evaluate. Now initially this looks a little yucky, but when we look at this, what we want to notice is that the part that's under the radical sign, its derivative is almost what's sitting in the numerator. In fact, the derivative of 1 minus x squared is negative 2x, which only differs from the numerator by a constant. That's the key. And the moment we know it differs only by a constant, that tells us that a u substitution might work. Because I've already used the letter u, I don't want to use it again. So instead of a u substitution, I'll do a w substitution. I'll let w equal the stuff under the radical sign. And then we'll take the derivative with respect to x. So we'll take dw dx equals negative 2x. And then we'll use algebra to separate the dx's and dw's. So multiplying both sides by dx, multiplying both sides by negative 1/2, we get negative 1/2 dw equals x dx. So we can replace x dx with negative 1/2 du. So we'll go ahead and make that substitution. So we get arc sine x. When we when we replace the x dx with the negative 1/2, the negative 1/2 will factor out in front of the integral, and that negative will give us will combine with this negative to give us a plus. So we'll get plus 1/2 the antiderivative of, and we're going to have 1 over the square root, and we've made a substitution, so we're replacing the stuff inside the square root with the w. And we had to replace x dx with the negative 1/2 dw. So there's the substitution piece. And then we want to recognize that if we have 1 over the square root of w, this is really just w to the negative 1/2 power. And that's probably going to be writing it as w to the negative 1/2. It's probably the easiest way to think about it. We do know how to integrate w to the negative 1/2. So we step over here, x arc sine x plus 1/2 of the antiderivative of w to the negative 1/2 plus a constant of integration. To integrate this, we're going to need to increase the size of the exponent by 1. So negative 1/2 plus 1 is positive 1/2. When we take the derivative of w to the 1/2, we need to get this back. So if we take the derivative of w to the half power, the half would come down. So we'll need a 2 out here to kill it to get that coefficient of 1 on the w there. So we get the 1/2 pops down, the 2 kills it. There's our antiderivative, and now we can clean things up just a hair more. X arc sine x, draw my x a little bit better, plus a half of 2 is 1, so we just get w to the 1/2, w to the 1/2 plus the constant of integration, but w is just 1 minus x squared, so we replace the w with the 1 minus x squared, and there we have the antiderivative of the arc sine of x.